Hello friends, welcome all of you. Today we discuss on 12th Science Physics pressure difference point with some MHT CET objectives with their proper solutions. So let's see the objective of this point. The first objective is the excess pressure inside one soap bubble is 3 times that inside a second soap bubble. Then the ratio of their surface areas is, and the options are: option A is 1:9, option B is 1:3, option C is 3:1, and option D is 1:27. So let's see how to solve this objective. Solution for this: as we know that for the Laplace's law of the spherical membrane, pressure having the formula, that means excess pressure P is equals to 4T divided by the capital R. So here pressure and the radius, these are in the inverse relation. So we have to get the formula, that is P1 divided by P2 is equals to R2 divided by the R1. So as per for the problem's given condition, P1, that means thrice P divided by the P is equals to R2 divided by the R1. So we have to get the ratio of the radius R1 divided by R2 is equals to 1 divided by the 3. This one is the ratio for the radius. So here we have to calculate the ratio of their surface area. So we know that surface area having the formula 4 pi r square. So for the first, that means S1 divided by S2 is equals to 4 pi R1 square divided by 4 pi R2 square. 4 pi gets cancelled. So here taking the ratio of their radius and having the squares, that will 1 by 3 square is equals to 1 divided by the 9. So here we have to get the option number A is correct. That means 1:9. So let's see second objective. The pressure of air in a soap bubble of 0.7 centimeter diameter is 8 millimeter of water above the pressure outside. The surface tension of the soap solution is, and the options are: option A is 100 dyne per centimeter, option B is 68.66 dyne per centimeter, option C is 137 dyne per centimeter, and option D is 150 dyne per centimeter. So let's see the solution for this. Here formula is the delta P, that means excess pressure is equals to 4T divided by the R. So pressure in terms of the height, density and the acceleration due to gravity, that means delta P is equals to HD into the small g. So taking outside the surface tension, that means T formula, we have to get the new formula from this. It is capital T is equals to RHdg divided by the 4. So putting the values in this formula, here diameter given it is the 0.7. So radius it becomes 0.35 into the 0.8 into 1 into 10 raised to minus 3 divided by the 4. So solving this step, we have to get the final answer. It is surface tension having the value 70 dyne per centimeter. That means it becomes 68.66, nearly about dyne per centimeter. So here option B is correct, having the value 68.66 dyne per centimeter. So let's see the next objective. When a large bubble rises from the bottom of a lake to the surface, its radius doubles. If atmospheric pressure is equal to that of the column of water height capital H, then the depth of lake is. Options are: option A is capital H, option B is twice H, option C is 7H, and option D is 8H. So let's see how to solve this. As we know that condition P1 V1 is equals to P2 into the V2. So putting the values of the given condition in this problem, we have to write this equation in the new format. That means P1, that means pressure, capital H plus small h into the rho into the small g, volume in terms of the 4 by 3 pi r cube is equals to P2, that means capital H as it is, and the V2, that means 4 by 3 pi into the bracket twice r bracket cube. So solving this step, we have to get the simple format. It is capital H plus small h is equals to 8 into the capital H. So outside taking the small h term, we have to get the answer. That means small h is equals to 7h. So here option C is correct. Let's see next objective. Excess pressure of one soap bubble is 4 times more than the other. Then the ratio of volume of first bubble to another one is. Options are: option A is 1:64, option B is 1:4, option C is 64:1, and option D is 1:2. Let's see the solution. Pressure delta P is equals to 4T divided by the capital R. So here taking the ratio of their pressures, that means delta of P1 divided by delta of P2 is equals to simply 4. So here taking the ratio of their radius, that means R2 divided by R1 is equals to simply 4. So taking again the ratio of their volume, that means first to the second bubble, we have to get V1 divided by V2 is equals to R1 divided by the R2 bracket raised to cube. So putting the values of this equation in this, we have to get the ratio. It is the 1 divided by 64. That means here option A is correct. Let's see the next objective. A spherical drop of water has radius 1 mm. If the surface tension of water is 70 into the 10 raised to minus 3 Newton per meter, difference of pressures between inside and outside of the spherical drop is. Options are: option A is 35 Newton per meter square, option B is 70 Newton per meter square, option C is 140 Newton per meter square, and option D is 0. Let's see the solution, how to solve this objective. Here water droplets. So here as per the Laplace's law of the spherical membrane, having the formula delta of P is equals to twice T divided by the capital R. So putting the values of T capital T, that means surface tension, and the radius, we have to get delta of P is equals to 2 into the 70 into the 10 raised to minus 3 divided by the radius, that means 1 millimeter, 1 into the 10 raised to minus 3. So here we have to get, calculating this term, we need to get the formula delta of P is equals to 140 Newton per meter square. So here option C is correct. Let's see the next objective. The pressure inside a small air bubble of radius 0.1 millimeter situated just below the surface of water will be equal to. Take the values of the surface tension of water. It is 70 into 10 raised to minus 3 Newton per meter, and the atmospheric pressure having the value 1.013 into the 10 raised to 5 Newton per meter square. Options are: option A is 2.054 into the 10 raised to 3 Pascal. Option B is 1.027 into the 10 raised to 3 Pascal. Option C is 1.027 into the 10 raised to 5 Pascal. And option C is 2.054 into the 10 raised to 5 Pascal. The solution for this objective is, we know that excess pressure inside an air bubble having the formula twice T divided by the small r. So putting the values as per our given condition of the problem, P inside, that means pressure inside, minus pressure outside is equals to twice T divided by the capital R. So putting the values of surface tension and the radius, we have to get 2 into the 70 into the 10 raised to minus 3 divided by 0.1 into the 10 raised to minus 3. So calculating this value, we have to get the pressure having the formula 1400 Pascal. So this value can be converted into the atmospheric pressure. So we have to get the pressure in, that means 1400 plus 1.013 into the 10 raised to 5. So we have to get the answer 1.027 into the 10 raised to 5 Pascal. So here option C is correct. Let's see the next objective. If the excess pressure inside a soap bubble is balanced by oil column of height 2 mm, then the surface tension of soap solution will be, radius given it is the 1 cm and density given it is the 0.8 gram per cubic centimeter. So let's see the options. Option A is 3.9 Newton per meter. Option B is 3.9 into the 10 raised to minus 2 Newton per meter. Option C is 3.9 into the 10 raised to minus 3 Newton per meter. And option D is 3.9 dyne per meter. Let's see the solution. Here the soap bubble, so here we have to write the formula, that means 4 by T divided by the capital R into the pressure having the value in terms of the height, density and the acceleration due to gravity, that means HD into the small g. So outside taking the surface tension term, we have to get T is equals to RHDG divided by the 4. So putting the values in this equation, we have to get capital T is equals to 10 raised to minus 2 into the 2 into the 10 raised to minus 3 into the 0.8 into the 10 raised to 3 into the 9.8 divided by the 4. So calculating this term, we have to get answer, it is 3.9 into the 10 raised to minus 2 Newton per meter. So here option B is correct. Let's see the next objective. Excess pressure in a soap bubble is thrice that in the other one. Then the ratio of their volume is. Options are, option A is 1:3, option B is 1:9, option C is 27:1 and option D is 1:27. Let's see the solution. As pressure is inversely proportional to the radius, that means delta of P inversely proportional to the 1 by the R. So we have to get the formula, it is R1 divided by R2 is equals to delta of P2 divided by delta of P1. So putting the value, that means 1 divided by the 3. So as per given condition, V1 by V2 is equals to R1 by R2 bracket raised to the cube. So we have to get the final answer, it is the 1 divided by the 27. So here option D is correct. Let's see the next objective. Soap bubbles can be formed floating in air by blowing soap solution in air with the help of a glass tube but not water bubbles. It is because options are, option A is excess pressure inside water bubble being more due to the large surface tension. Option B is excess pressure inside water bubbles being less due to the large surface tension. Option C is excess pressure inside soap bubbles being more due to the large viscosity. And option D is excess pressure inside water bubbles being less due to the less viscosity. This objective is based on our theory knowledge. So here option E, that means correct answer, it is the option A, that means excess pressure inside a water bubble being more due to the large surface tension. So today, friends, we discuss on the pressure difference point with some MHT CET objectives with proper solution. In the next video, we discuss the new point of the physics.